Hello everyone, I'm here to talk about voltage dividers, which we go over in our Diving into Hardware class. On this piece of paper in front of us, I have two things. I have the circuit schematic for the voltage divider itself, that's on the left, and I have the mathematical equation that governs the way that voltage divider behaves on the right. So why don't we jump in by discussing the circuit and hopefully try and figure out what it does. First of all, I have V in, which simply means I have some amount of voltage going into the circuit. This is the high voltage, this is the power source. It could be any number. For us, it'll probably be, 5 volts. Depending on the situation, it could be, 9 volts, it could be 20 volts. I'm just leaving it very general by saying V in rather than actually putting a number there right now. We'll do an example a little later with a specific input voltage. I also have 2 resistors in this circuit, so that electricity to get from V in to ground has to go through both of them. And then I also have, splitting the 2 resistors in between the two, I have a little wire here going to this symbol, V out. So I also have some voltage coming out of the circuit as well. So this circuit is supposed to, as its name would suggest, divide the voltage. So it's going to split our input voltage. How does it do that? So these 2 resistors here are vital in making sure that it can actually do its job. So if I have a very large input voltage and I want a smaller output voltage, maybe I don't want to work with the full voltage, I want to work with a smaller amount of voltage, this is the circuit I would use to do that. As a matter of fact, the Arduino Unos that we use do something along these lines. So we plug in a 9 volt to the Arduino Uno, yet it typically only uses the 5 volts to power like the internal chip, and when we want to power something else from the board, we're only using 5 volts as well. So somewhere inside the Arduino Uno is a circuit very much like this. Maybe it's a little more complex, but it's more or less a voltage divider. So the question is, how are these resistors accomplishing that? As it turns out, voltage gets dropped slightly over each resistor, and how much voltage gets dropped depends on how big or how small the resistor is. So say, for example, V in is 5 volts. Maybe after electricity flows through R1, the voltage here, and therefore the voltage here, is not 5 volts anymore. Maybe now it's only 3 volts. And then from here to here, it drops down to ground, which is 0 volts. The idea is that between here and here, voltage has to be reduced from whatever that input voltage is, all the way down to 0. So if we're clever enough, we can come up with a specific number that we want V out to be, and plug in resistors of certain values to give us exactly that voltage, so we don't have to do any guesswork. And the way we can accomplish that is actually through this equation. This equation lets us take the guesswork out and help us figure out exactly what we need those 2 resistors to be in order to get the output voltage we want. So if we look at this mathematical equation, it's just saying that the voltage out is equal to the voltage in times some fraction. So this fraction says R2, this resistance here, over R1 plus R2, which is the total resistance of the entire circuit. So basically, the amount of voltage we're getting out is dependent on how big R2 is compared to the total amount of resistance there is total. So I understand some of us might be a little iffy on the math, so let's try and come up with a simple example to show us how this works, show us this in action. So let's say I start with 5 volts. 5 volts is my V in, and my first resistor is 100 ohms. And my second resistor is 400 ohms. So total, the entire resistance in this circuit is 500 ohms. I only have 1/5 of that here. So 100 is 1/5 of 500, which means from here to here, only 1/5 of the voltage gets lost. So I drop from 5 volts down to 4 volts going across this resistor. So therefore, V out is 4 volts. And likewise, I drop 4/5 of the voltage here, which gets me from 4 volts down to 0 volts. So that's a very, very simple example where I pick the numbers so that they work out nicely, so I don't have to do too much difficult math. But we'll get to a little more practical example in a second as we try to wire our own voltage divider out.